These are the answers to the review sheet for the Unit 10 on counting and probability. So our first question, we have Mr. Siegel's daughter, Annie Rose. She's got 7 songs that she's going to listen to. She's going to choose first, second, third, and fourth song. We've got 2 ways to do this. Either you can look at her making choices and saying that she has 7 choices, 6 choices, 5 choices, and 4 choices for each song, decreasing by 1 so that she doesn't listen to the same song twice. We can also write that as saying, well, she has 7 songs total to choose from. She's going to choose 4 songs, which means she's not going to choose about 3. And I care about the order, so I don't divide by the 4 she is choosing. These 2 things are actually equivalent. And in your calculator, if you want to, we can do this as 7 factorial, which we know comes up in the math menu. Go to the left to probability and down to 4 number factorial, divided by 3 math factorial. And we get, what is that, 840. If she just wanted to pick 4 songs to listen to, then we would either take the same calculation as above and divide by the order of the 4 songs, or we have our formula, which is there are 3 songs she's not listening to, 4 she is listening to. We don't care about the order. We can plug that into our calculator. It's the same thing we did earlier, but now we want to have 2 things in the denominator. Make sure we have parentheses around those. And factorial. And we see that there are 35 songs. So this is a permutation in question 1. And this is a combination in question 2, based on the fact that we want or don't want order. And again, the difference is that order matters in number 1, doesn't matter in question 2. If I have 10 books and I want to pick 3 of them to take to Champaign, how many ways can I make my choice? Here I don't care about the order. I just want to pick 3 books. So 10 factorial, that's my total. I want 3 books. I don't want 7 books. I plug that into my calculator. I can do 10, and to do this the fast way, instead of using the factorials, we're doing a combination of 3 books, and we get 120 books. If I invent a new sport, I have to decide on the equipment I'm going to use. I'm going to take some of this equipment from the gym. I know that there are 8 different kinds of choices for a ball, 4 different things for a racket, and I can choose one of 5 different gyms to play in. It shouldn't be 5, that should say gym. So I have 8 choices, 4 choices, and 5 choices. I'm going to pick one from each and multiply those together to figure out how many different sports I could make. And 20 times 8 is 160 possible sports, not even starting to count the rules. I really want my sport to use a tennis ball and be played in the field house. And then a friend of mine is going to make a choice, which really is only a choice for the racket. So there's 2 ways we can do it. Either you can say that there were 160 different choices. I have to divide by 8 and by 5 because I'm not going to choose a ball or a gym. Or I can say I have a ball, racket, and a gym. This time I really want to use a tennis ball, so there's only 1 choice. I don't care what racket I use, and I want to use the field house, which gives me a total of 4 sports. Here we've got this geometric probability problem. I'm throwing a dart at the trapezoid, that outside shape, and I want to know what's the chance that it hits a circle. To do this, we need to figure out really how do their areas compare. So the area of the circles is the area of one circle times 2, because they're the same circle. The area of a circle is pi times the radius, which is 5 squared. And the area of the trapezoid, which is our shape here, is 1/2 the first base plus the other base times the height. Well, we need to figure out what the height is. The height in this problem is not actually given to us. So based on this, I would say that there isn't a way to do this. However, if we can say that this distance across is the height across the circle, which is what I'll change the problem to be on the problem that you're given, we can say that we have 5 and 5, which means we have a height of 10. And I want to know, how does the thing that we want compare to the total? So we have 2 times pi times 25, because that's 5 squared, over 18 and 24 is 3242, and half of that is 21 times 10 is 210. And that you can plug into your calculator to get your probability. Sorry. So 2 times 25 times pi divided by 210. We have a probability of about 75%. In a table, we have a few questions. What's the probability that a student is male? Well, I know that there are, looking at my first column, 58 male students. And I know to divide that by the total number of students, which is 108. Probability a student is a female 10th grader. That means that she is both of those things. There are only 7 female 10th graders out of 108 total. Given that a student is in 10th grade, so now we're only looking at the 10th grade row. So there's only 44 of those students. What is the chance that that student is female? Well, there are only 7 of those students. These numbers do not add up. We're going to have to make sure we change some of these. Let's double check a couple of those. 7 and 27, 15 and 9. That is 58. 4, 7, 18, 11. That is 40 instead of 50. This should be a 17. So this will change to a 17, and that would change to a 17. I'll change that on the copy I give to you guys before I make copies. What is the chance that if a student is male, so now we're only looking at the male students, there's 58 of those, that student is in 11th grade? They're 15. What is the probability that a student is male or in 10th grade? Not a given here, so we're out of the 108 students total. There are 58 male students, plus there are 44 10th graders, minus the ones that are both male and 10th grade, which is 27 students. That would be a total of 17 on top of 58 is 75 out of 108. Now we're going to have to fill in the information for ourselves. A movie theater takes this survey on a Friday night. This is must have been made last year when Iron Man 3 came out. There were 1,243 people total surveyed. Each person is either going to see Iron Man 3, Oblivion, or something else. So we have Iron Man 3, Oblivion, or other. Each person is either male or female. Ooh, that got me too. There's don't need to worry about male and female. Instead, we're looking at age demographics. So we're looking at 17 and below, 18 to 25, and 25 and above. And we've got our totals. So now let's start filling in some information. I know that there were 620 people saying they were going to see Iron Man 3. 302 said they were going to see Oblivion, which means that if I take my total of 1243 and I take away 302 and I take away 620, we've got 321 people seeing something else. We know that there are 356 people between the ages of 18 and 25, 200 of which were seeing Iron Man 3. 446 were over the age of 25, and half of them are going to see Iron Man 3. That's 223. 107 people from every age group were going to see something other than the 2 movies. So 107 for each of these. And now we need to fill in the rest of the information. So to figure out the last Iron Man 3 spot, I'm going to take 620, take away the 223, take away the 206. We have 191 people under 17 seeing Iron Man 3. We can figure out the final total spot on the right. So we've got 1243, we take away 446, we take away 356, and we get 441. I can get all the other spaces in between here by subtracting. So if I do 441 and I take away 107 and I take away 191, I get 143 going to see Oblivion. If I do 356, I take away 107 and 200 even, I get 49 seeing Oblivion. And 446, I take away 107, I take away 223. I've got 116 people seeing Oblivion. And now I can answer the questions below. What's the chance of someone seeing something other than Iron Man or Oblivion? There were 321 people seeing something else out of 1,243. Given that you are in the 18 to 25 bracket, that's 356 people, what's the chance you see Oblivion? There were 49 of those people. Given that you were seeing Iron Man 3, so that's 620 people, what's the chance that you were under 17? It's 191 people. What's the chance that you see Oblivion and are over 25? Oblivion and over 25 is 116 people. We're not given anything, so it's out of the total. The chance that you see Oblivion or you're over 25. Again, we're out of the total. Oblivion, 302 people. Over 25 is 446 people. Take away the overlap of 116 people, and we get a total of 302 plus 446 minus 116 is 632 out of 1243. Last page. If we have a jar of marbles, 10 blue, 6 green, 7 white, 10 and 6, and that is 23 total. What is the probability that marble is green? 6 out of 23. Pick 2 marbles without replacement. What is the probability that they're both green? Without replacement means we're going to lose marbles as we go along. So 6 out of 23 times 5 out of 22. That is 6 times 5 is 30. 23 times 22 is 506. 30 over 506, which can reduce if you'd like to. If you pick 2 marbles with replacement, what's the chance that they're both white? Now we're going to put the marbles back. So a 7 out of 23 chance for a marble that's white. And we put it back, so it stays 7 out of 23, which is 49 out of 529. What is the probability that you pick all 7 marbles in a row as white without replacement? We have 7 marbles that are white over 23, and then 6 out of 24, and then 5 out of 23. Oh, ooh, that went up. I should have gone down. Word. These are wrong. These should be, 22, 21, 4 out of 20, times 3 out of 19, times 2 out of 18, times 1 out of 17, which is 7 factorial over 23 factorial over 16 factorial, which I will put into my calculator, and we can do 27 factorial divided by 23 factorial and 16 factorial, and I get a very small number. That is about 0.1234547. If you pick a marble, what is the probability it is green or white? If it's green or white, it could be 6 that are green plus 7 that are white. There are none that are both, so there's nothing to subtract out of 23. If you pick a marble, what is the probability it is blue or white? There are 10 blue marbles, 7 white out of 23, none that are both, so we can not have to subtract anything. What does it probably pick? Blue, then green, then white with replacement. With replacement means that we're going to put those marbles back. So 10 out of 23 for blue, 6 out of 23 for green, and white, 7 out of 23. Don't worry about the denominators changing because we're putting the marbles back each time. That's 420, and 23 times 23 times 23 is 12,167. What does it probably pick? Green, then white, then blue without replacement. Without replacement, we have green, 6 out of 23, then white, 7 out of 22, then blue, 10 out of 21. We get, again, 420 out of 23 times 22 times 21 is 10,626. All right, we've got Jose Abreu. He has a plate appearance. He's coming up to hit. He has a 9% chance of hitting a home run. What is the probability he hits a home run on back-to-back plate appearances? So he has a 9% chance the first time. That's 0.09, not 0.9. And then the second time, 0.09 again. So we have to multiply those together because it's a home run and another home run. That is 0.0081. Chris Sale wants to know what's the chance he hits or strikes out the side. 3 strikeouts in a row. So he has a 0.26 chance, a 0.26 chance, and a 0.26 chance. Together, 0.26 to the third is 0.078. A 10-sided die, numbers 1 through 10. What is the probability I roll a 2, 3, or 6? That's 3 outcomes out of 10. If I roll an even number and then an odd number, even numbers happen 5 out of 10 times. Odd numbers happen 5 out of 10 times. I want both to happen. I multiply them together, and I get 25 out of 100, which is 1/4.